All right, welcome everyone to part 4 of Mathpix in React. So in part 4, we're going to be implementing um, basically the response that we get from the fetch request and basically using this to do a bunch of things, a bunch of useful stuff. So first things first, we want to install Mathsteps, which is another API. So to do this, it's really simple. Just npm install Mathsteps in your terminal here. Um, Obviously, as you can see, our server is running, so and I already have it installed. So all I have to do is say const Mathsteps equals require Mathsteps, and we have Mathsteps um, now inside of our file. And this takes a second to compile. All right, looks good. And everything runs well. Okay, so as you can see, Mathsteps is pretty much um, the idea of taking um, a string, specifically a string equation such as this, and putting it inside of um, Mathsteps, which then gives you back something like um, a bunch of things like before change, change after change, and the number of substeps. Specifically, what we want to find is all the steps it takes to solve an equation. In our case, the example PNG that we've been looking at for a while now. So we basically want 16 minus 2t equals 5t plus 9 to basically go through, specifically solve equation, and be able to solve what this is supposed to be, right? So um, let's get this started. So math steps up here. Let's do this. Base 64 here. We actually don't use this anymore. Um, and so right here, we are only getting the response being logged. We don't need to do that anymore. Um, so what specifically do we want from response? So if I were to say console.log response, we would get that whole JSON back, right, from the last video. So what if I say response data, right? And I need to put the app key back in, so let me just do that. All right, so this is compiled. If I throw this in here, response data gives us an array of two objects, which is ASCII math and latex types and values, right? So specifically, let's try to grab ASCII math and specifically the value, right? So let's say we want response data 0, which will give us the first object, and then we're going to get the value, right? And if you remember, there is a confidence and a confidence rate in the response. So we are going to say something like this before we actually grab this. So I want to say if response of confidence is greater than or equal to 0.60. So we're saying if there is a 60% confidence rate coming from the response, then we're going to say, okay, fair enough. It's good enough for us. Let's take it, right? So if it's that confident, let's get the math steps of this equation, right? So let's say this dot get math steps response data 0 value. And we can get rid of this now. Can save this, see if everything compiles. Looks good to us. So now we have get math steps. Let's just put this up here. This dot get math steps equals this dot get math steps dot bind this. All right, so now let's have an equation called get math steps, and we have a problem or an equation. Let's just call it problem for now. And basically, we want this response here to go through and basically do the same things that are happening here to grab all the information that we specifically want. So, specifically, we want a list called problem steps, and we're going to call it an array, right? So we are going to say this dot set state of problem steps to be empty here because the page doesn't refresh when we upload new pictures to the drop zone. So we need to we need to empty the problem steps every single time, right? So moving from here, let's say if problem dot includes some JavaScript dot includes an equal sign. We're going to say this is a solve problem, right? And then so let's just take all the solve problem stuff and let's copy paste this. Let's go here. And we know this is a solve problem. And then we're going to say else. If it does not include an equal sign, we know it's a simplify problem. So we'll take all this simplify problem stuff and then we'll just copy paste this here. And then we will get rid of this arbitrary stuff right here. We'll now say this is problem, and we'll say this is problem here as well. So let's actually look at this real quick before we just jump into it. So const steps equals math steps dot solve equation for problem, and this is the same except it's a simplify expression. So we then get the steps up here for each step, and we get every single step that is required to solve this equation up here. So we get the before change, we get the active change, which is, in this case, simplify left side. We get the after change, so this goes to that, and we get the number of substeps that takes. So for the most part, a lot of this information isn't really required of us. Really, all we want is the before change. So we are going to say this dot set state, and we actually want, because this is going to be an array, we're going to have to say previous state of this. Shoot, how does this usually look when you put a prev state? Prev state, and you say this. Okay, and then you say problem steps, and you have prev state dot problem steps. So basically everything in problem steps plus the new thing that you're adding in. In this case, we want every single before change step, which basically is going to show us every single thing that we want, if I recall. So this should be that. And then we say the same thing down here, somewhat. So problem steps, previous state problem steps, step dot old node, oops, dot to string. So it is actually different from the one above. So we know this is solve. This is a simplify expression. And everything should compile. It goes through. But how do we actually see the changes when we add or when we drop something into the drop zone? How exactly do we see these changes other than just seeing a bunch of console.log stuff, right? Do we really care about a bunch of stuff in the console.log? Not exactly. So let's actually see this stuff go, or rather be rendered on the page. So we can do something like this, where we can actually lay out an array or a list. So we can say this dot state dot problem steps, and we map out all the pieces from this list by saying function d, and then we have this happen, and then we now say return, and this is pretty simple. We can just say here's a div of d, and let's compile it. Everything goes through. Let me put the app key back in, and then let's check to see if everything works correctly. So give me 1 second here. All right, everything compiles correctly. Let's refresh this page, get rid of all the other stuff on the page. So console.log is empty here. Now if I am to say I get my example, I put it here, I put it down, and now actually a lot of stuff had just happened. So for one, all the math steps specifically pertaining to 16 minus 2t equals 5t plus 9, which we know is the equation that we just submitted, right? And we can see every single thing that it takes to basically solve it, right? And it ends up becoming t equals 1 down here. And here is a simplified version of this down here, where this is every single before change. So we actually see every single change here up until the very last thing, which is supposed to be t equals 1. And as you can see, I mean, we pretty much solved it. We can see every single step that it takes to solve this image. So we basically went from having an image, being able to submit that image to our drop zone here, having that image be processed into a base 64 string. That base 64 string then gets put into a fetch request, which then goes through Mathpix, gives us back a bunch of feedback and useful information, and we basically used that useful information to pretty much solve that equation, right? You can see right here that at the end of the day, if we were to solve this, the answer should be t equals 1. That is amazing. So that's pretty much the end of our tutorial series. Um, I could um, modify the current code that we currently have and actually allow it to um, basically take in a picture that has multiple equations on it. And that will probably be part 5. But for the most part, the tutorial is pretty much finished. As you saw, you got an image, and that image went from a base 64 string, and that base 64 string gave us back useful information, and that useful information was then solved here. And that's pretty much the um, everything I was trying to get at from the beginning of this tutorial. So if you guys like that, please like and subscribe. Please hit the bell on your way out. And please continue supporting me on my venture in doing coding and recording coding. Thank you very much. See you guys next time.